This week on the show, we describe upgrading OpenBSD procedure a little bit. We ask, where do Unix man pages come from? Help from NetBSD's VAX port is required a little bit. FreeBSD on the Dell Latitude is described by Colin Percival. The PFS tool changes in DragonflyBSD is what we talk a little bit about, and more in this week's episode of BSD Now. BSD Now, episode 355, Man Page Origins, recorded for the 17th of June 2020. This episode is brought to you by Tarsnap, the online backup for the truly paranoid. Hi, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Welcome to this week's episode, everyone. We hope you had a nice week, but your week is not complete without an episode of BSD Now, I would say. So we should get right into it. The headlines this week start with how to upgrade OpenBSD and build a kernel.
Yeah.
So that goes easily enough by introducing what OpenBSD is. That's fairly well known if you have a regular listening to this episode or to this show already. But they ask, let's see how to upgrade your OpenBSD system. Maybe you're doing this because the latest release just came out, or there's other reasons. But if so, this is pretty simple. Back up your data, boot from install media, and select upgrade instead of install. But maybe the latest release has been out a few months. Why would we go through the trouble of building and installing a new kernel or other core system component? Maybe some patches have been released to improve system security or stability, which is OpenBSD's focus. It is pretty easy to build and install a kernel on OpenBSD, easier and simpler in many ways than it is on Linux. So first, you need to verify that you have the real operating system because, well, there might be something slipped in there that shouldn't belong. But if you have purchased, that's a bit older way of getting OpenBSD. If you have purchased OpenBSD Media, then you have the real operating system. But what if you download it? From the 5.5 release onward, you have the signify command along with the needed public keys in the etc signify directory. I shouldn't say signify, it's signify. The OpenBSD project generates the key pair from the next release ahead of time, so you already have the public key for the next release. Once you have a trusted etc signify key collection, upgrade to every release, and you can always verify things as you go. And they talk a bit about how the Linux kernel signing model is different than that, but this is not too important for this actual artifact or the article. The good news there is that OpenBSD is that the security tools and keys are in place. So you just have them and use them to upgrade to the next version. So if you're preparing an upgrade to a new release, go to the appropriate architecture-specific directory on the OpenBSD ftp/pub/OpenBSD and then replace the version number there and then the architecture you're using and download the appropriate bootable image. That's also named after the release, like CD 3.5 or whatever you want to go to. Of course, this should be an upgrade, not a downgrade. And the verification signature, so you can see that the stuff you downloaded is actually the stuff on the web and not something that was changed between there. And now you can run signify by verifying the signature that you downloaded from the one that is available by the operating system. And that way, Signify will tell you, yes, this is authentic, this is trusted, and can be used to upgrade OpenBSD in place. And they give you warnings, of course, if it's not, and you should heed those warnings that something's different. And then you can prepare the update, make sure your data is safely backed up before you proceed, of course. Always do backups. And that way you have a way to get back your data if something goes wrong. To finish the upgrade, you would run the sysmerge program to upgrade the configuration files, of course, because they might have newer content in the new version. And if you're building a new kernel, you can skip ahead a little bit to the steps needed to upgrade the packages. But if you're going to build a patched kernel, there is extra instructions to install the source code, apply these patches, and prepare to build the kernel. All of this is described in this article, and it's fairly easy to follow along and make your own kernel and upgrades on your system. All right, then, as a new article in this week, we have the history of man pages.
Yes, so this is over at manpages.bsd.lv, and it's an appendix to the Practical Unix Man Pages website or book or whatever. And it says, where do Unix man pages come from? who introduced the section-based layouts with, name, synopsis, examples, etc. And for people that have to write man pages, where do all these little 2 and 3 letter acronyms actually come from? And why do we have these specific ones and not some other ones, and so on? The many accounts available on the internet often lack citation and are at times inconsistent. In this article, I reconstruct the history of the Unix man pages based on source code, manuals, and first-hand accounts. So, special thanks to Paul Pierce and his CTSS source code archive, Bernard Nevelet of the Multics Internet Server, the Unix Heritage Society, or TOOS, especially for their research Unix source reconstruction. So, building back a repo of what some of the original versions of Research Unix look like. Gunnar Ritter from the Heirloom Project's source code, the Alcatel-Lucent Bell Labs, and the Plan 9 source code, BitSavers for the Historical Archive, and last but not least, of course, Rudd Kennedy, James Clark, Brian Kernighan, Doug McElroy, Nils Peter Nelson, Jerome Salzer, Henry Spencer, Ken Thompson, and Tom Van Vleck for their valuable contributions to this. And there's some more details about that there. But he has a nice little timeline here. The development of Unix man pages can be divided into prehistory, before Unix, the classic age during the development of Unix, and the Renaissance, where traditional Unix utilities were rewritten. In this chart, I show all known formatters for man pages and their logical precursors before man pages, including the original run off, which then led to, I think I can zoom in on this image a little bit. So run off, which eventually led to ROF and the script language, and then that ran to run off in lowercase, which also led more to ROF and RF and compose, and then ROF turned into NROF, turned into TROF, into DITROF, which made a different version of TROF, which then eventually made GROF, and then that led to Mandoc, but also into AWF and CAWF. And so there's history and citations and so on for all of this, talking about the original runoff in 1964 to the original Robert Morris version of ROF in sometime around 1967, then Doug McElroy's rewrite of runoff in 1969, which then eventually led to Compose in 1974, or Brian Kernighan's ROF in 1969, and then NROF by Joseph Osana in 1972, and then that became TROF, and then later we also got DITROF and more, and then we see the GNU version of TROF that was popular in Linux, and then also how back in 2008 Mandoc came about, and which was kind of like AWF. Mandoc primarily reads DITROF macro files, although it has some capabilities for generalized input, and it is the first full semantic parser for man pages, exposing the annotated contents of parsed documents. But, obviously making it read any man pages that GROF could read was the predominant point of building Mandoc. And they note that, the person writing this history is the person who originally wrote Mandoc, Kristaps Johnson. So
yes,
you can keep that in mind.
Oh yeah, the history is not stopping. It's going on.
Yeah, there's a lot more citation and details in here than any of the accounts I've seen before. So it's very nice to have this all collected with links to actual emails that Kristaps got from people like Doug McElroy back in 2011 and so on, and preserving all of that because kind of the history of oral tradition doesn't hold up so well when the people that were there aren't around to tell the stories anymore. So capturing as much of that as we can while people still remember it and might still have files and backups and emails from the time is really important.
Yeah, and each time you hit up man to, look up the G option to ls, whatever it might be, then you kind of are part of this history or the people that have built this. So
well, I was helping Dan Langille turn on the right blinking LED for a failed hard drive at his house, and I had to refer to the man page that I wrote for a tool that Baptiste and I built because I didn't remember how it worked, even though I helped write the damn thing.
Yeah, that's why we have man pages. There are brains in our little helpers here and there in case, because we cannot keep all the options in our heads. That would be too much. But the man pages are there to help us, and we can read them and find usually very quickly what we're looking for, and then we can just put them back where they where they are in the man page directory or in the man page memory, and then go on our happy ways. Yeah, and thanks for the people who are doing all this historical digging and asking questions and how was it back then. It's kind of important to have this preserved in case, as Alan mentioned, the people are not around anymore. All right, speaking a little bit more about historical artifacts, we have a call for help of sorts on the NetBSD blog about VAX port needs help. Martin Huseman writes that the VAX is the oldest machine architecture still supported by NetBSD. The support for it sometimes causes heated discussions, but it also has benefits. For example, it uses a pre-IEEE 754 version of floating point numbers, while all other later architectures use some variant of IEEE 754 floating point in hardware or emulate it. Another one would be that by today's standards, all machines are slow and have little memory. These this is a severe challenge for a general purpose operating system like NetBSD, but also provides a reality check for their claim to be a very portable operating system. Unfortunately, there's another challenge totally outside of NetBSD, but affecting the VAX port big time. The compiler support for VAX is, let's say, suboptimal. It's also risking to be dropped completely by GCC upstream. Now here is where people can help. There's a bounty campaign to finance a GCC hacker to fix the hardest and most immediate issue with GCC for VAX. Without this being resolved, GCC will drop support for VAX in the near future version. And they have a link to that campaign so you can back this.
Yeah, well, you can see why people are not putting a bunch of effort into supporting the VAX. And, at some point, there's, even if the VAX obviously doesn't change, that having that old code around can end up making it harder to write new code and support additional platforms, or even just to do the testing to make sure that we haven't broken VAX every time you make a change. At some point, it might not be worth doing anymore, in which case, maybe it makes sense to just keep using an old version of GCC that does work on the VAX and importantly handles, the VAX's lack of large amounts of memory and so on.
Yeah, there's a question in the comments about Llvm support for VAX.
Yes, I think Llvm is much newer and it never made sense to build the VAX bits. With GCC, technically that source repository goes all the way back to when VAXs were still a thing people did. Whereas Llvm is so much newer, I don't know that it ever made sense to build support for VAX. There are some other platforms like Spark that are much newer, but still not supported properly or completely in Llvm, where it might make more sense. Well, Spark's a bad example because it probably doesn't make more sense to spend time on that. But maybe the newer PowerPC, Power 9 stuff is an area where it would make more sense to spend the time for Llvm than on VAX.
Yeah, if you have one in your basement, then maybe you can support this issue or this effort. Would be nice to have this just a little bit longer around.
Yeah, and somebody else in the comments makes the obvious point of, is there actually value in allocating development resources, financial resources to support a system that you can't actually buy anymore because it's been out of date so long? This is an essential question as NetBSD's resources are scarce and supporting antiques is done to the detriment of possibly contemporary platforms. Of course, it runs NetBSD, may be better applied to newer things rather than older things.
And they have proven that they were running on VAX and are running. So they can say, okay, up to this point, we ran on VAX while other operating systems already have dropped support years ago.
Something we've talked about before is sometimes if you want to run a computer from the 1990s, you should use an OS from the 1990s.
Right.
Whether that's just an older version of a modern OS or some OS that's not around anymore, that's kind of up to you.
Yeah, we'll leave that to the historians what to choose. A little bit more modern machine is what we have in the next article about bring up of FreeBSD's support on the Dell Latitude 7390.
Yeah, so this is a blog post by Colin Percival over on his blog, and he says, as a FreeBSD developer, I make a point of using FreeBSD whenever I can, including on the desktop. I've been running FreeBSD on laptops since 2004, and this hasn't always been easy, but over the years I've found that the situation has generally been improving. One of the things we still lack is adequate documentation, however. As I'm writing this to provide an example for users and also Google bait, in case anyone else runs into some of these same problems, I had to address. So a few months ago, after my System 76 Galago Pro had its second experience with a swelling, dying battery, I decided it was time to replace the machine entirely. So on February 15th, I ordered a new Dell Latitude 7390. This is an older model of laptop. It originally launched in 2018, but I've always found the Dell Latitudes to be well built, and this one came with a very attractive price tag. Rather than the original price of $3,600 Canadian, about $2,600 US at the time, Dell Canada was selling this laptop for only $1,049 Canadian or $750 US. I can only assume that this is the last of their stock and they really wanted to clear it out to make room for newer models. But this laptop is quite modern. You get an Intel i7 8650U, so that's quad core with 8 megs of L3 cache, 8 gigabytes of RAM, a 256 gigabyte M2 SSD with Windows pre-installed, a 13.3-inch 1080p display with no touch, an Intel 8265 Wi-Fi chip, and a 60 watt-hour battery. The laptop finally arrived on March 6th, and I made a couple of upgrades, replacing the 8 gigabytes of RAM with 16 gigabytes for an extra $90 Canadian, and replacing the 256 gigabyte SSD with an Intel 512 gig NVMe disk, another $95 Canadian. So in addition to giving me double the disk space, upgrading the disk allowed me to keep the Windows installation intact in case I ever want to run Windows on this laptop. After these upgrades, I didn't quite have my ideal laptop. I would have preferred 32 gigs of RAM, which Dell's specifications state that this laptop supports a maximum of 16, and I would have liked to have a second disk. Theoretically, the Llvm PCIe slot, designed for a 4G modem, can hold an M2 2242 NVMe disk, but comments online suggest that the Dell BIOS doesn't allow SSDs in that slot, and a track stick, but for what I paid, I can't really complain. Anyway, down to installing FreeBSD. So I downloaded the memstick image for FreeBSD 12.1, the weekly snapshot, using my old laptop and wrote it to a USB disk. Normally, I would use a release, would make a lot of these later steps easier as well, but a few recent changes I had made to some of the code needed to support the I2C touchpad were not in that release yet. If you're reading this a couple months from now, you can just use 12.2 and not have any problems. To boot from a USB stick on the Dell Latitude, I needed to press F12 when turning the system on and enter the boot disk selection menu. Installing FreeBSD was easy for me, as I've done this many times in the past, but I did change a couple of the defaults. When selecting which parts of FreeBSD to install, I included the source distribution. Normally, I wouldn't do this, but I needed the FreeBSD source to build the graphics driver module. When configuring ZFS, I turned on full disk encryption, as I've done on all my laptops recently, and I increased the swap size from the 2 gigabyte default to 16 gigabytes. I hope this system will never need to use that much swap space, but if it's 16 gigabytes of RAM isn't enough, it's unlikely that 2 gigabytes to swap is going to be enough either. Also, it means a better chance of being able to capture a crash dump if something does go wrong. I turned off SSHD. I don't intend to connect to this laptop remotely, but I did turn on NTPD and PowerD. I want the clock kept accurate and to save power when I'm not using all of the CPU. Of course, you can do these later via rc.conf, but the installer has a menu, so why not? From the system hardening screen, I enabled the clear/tmp, disable syslogd, and disable sendmail options. The first two are just on principle, while sendmail is something I don't use and don't want. I will be using qmail. I don't enable any of the other hardening options since they don't have any significant benefit but removing functionality which I happen to find useful. When creating my cPersiva account, I added the account to the wheel and video groups. The former is necessary so I can use su to root, and the latter is necessary for applications to access the accelerated video functionality. If you forget these, you can log in as root and do them later, but that's a nuisance. In general, you might also want to add yourself to the operator group, which allows you to do reboot and shutdown as a non-root user. After the installation completed, I asked the installer to reboot the system and I unplugged the USB disk. So once FreeBSD was installed, I disabled the terminal bell because it's annoyingly loud and not helpful. Then I told FreeBSD to use link aggregation networking to fail over automatically between the wired and wireless Ethernet. And he has an example of the config there. Then he set his Wi-Fi credentials up, adding his SSID and password and so on, and got all that started and set up a simple PF firewall. And he said, now for the most annoying part, because I'm running 12.1 stable rather than 12.1 release due to the aforementioned patches for the touchpad, I couldn't rely completely on packages built by the FreeBSD project. Instead, I needed to build two packages, the DRM kmod and the IIC HID, from the ports tree to get those two drivers working. So he used PortSnap to download the ports tree, another tool that Colin wrote, an important part of the FreeBSD based system. And then he built the ports DRM kmod and IIC HID. And then he used package lock to prevent those two packages from being automatically upgraded by the package tool, since the versions from the official repos wouldn't match his kernel and would cause a problem. Again, if you're using 12.2, which isn't out yet, but might be by the time you're reading this, you can just package install those two and not have to worry about it. Then he also package installed Xorg, KDE5, and SDDM, and then followed the instructions from the DRM kmod module to load the i915 KMS driver and the IIC HID touchpad driver, and then told his Xorg to use lib input to get the touchpad, and enabled the SDDM so he would get a graphical login screen. So at this point, I can reboot and watch my laptop automatically start into a GUI and log in as the C Persiva user. Then I can open a console, Control-Alt-T, and use su to become root and do anything else I want to do. So he made some changes, setting some specific settings to get his speakers and headphone jack being independent audio inputs. This isn't what he wanted. He would like to have sound go out of the speakers by default, but switch to the headphones and mute the speakers automatically when you plug in headphones. To do this, I told FreeBSD the headphones, which are NID33, to become part of the same audio set as the speakers. He also disabled the power well option on the graphics driver to stop an annoying warning he was getting, and there's more explanation of that. And he enabled dbus because KDE heavily depends on that. Then he adds some bits to automatically update the Intel microcode on his CPU to make sure all those Intel CPU mitigations are applied, and change the auto boot delay in the boot menu to 0 so that it doesn't waste 10 seconds during boot. And also told it only to wait 1 second for USB disks, so his system won't stall waiting for USB disks. Then he has a more complicated setup where he's using spiped to forward his mail off to a Qmail server, but you probably don't need that one. Then he has the setup for getting his webcam working, which is basically just configure webcamd and making sure his user is in the webcamd group. And then he installs some FreeBSD wallpapers for KDE. Then he gets printing working, the backlight controls, and then installs, Firefox, LibreOffice, Thunderbird, Chromium, Nano, Conversation, the IRC client, Git, Subversion, diffstat, portlint, lots of other tools. And of course, package install tarsnap.
Last but not least.
And finally, we want to perform hourly backups, which he shows you how to do easily with tarsnap. And then he plays with KDE a bit. So in summary, where are we? Graphics work, backlight controls work, the keyboard backlight works, the touchpad works, volume up and down keys are working. The mute hotkey does not seem to work. That's interesting. The mute on my Lenovo is hardware, and so it doesn't require any software to work. Ethernet is working. Wi-Fi is working. Bluetooth he did not test. The fan seems to be automatic and only come on when needed and not too often. The SD card reader he has not tested yet. Suspend and resume works. The webcam works. HDMI works. USB works. Audio is working, and auto switches when he plugs in headphones and everything. And his battery lasts 8 to 12 hours under typical use depending on his backlight brightness, but only lasts a little over 2 hours when he's maxing the CPU out doing a full build world on all 8 cores. So after the above installation and configuration, it took about 75 minutes, mostly spent downloading the 4 gigabytes worth of packages. There's just one thing left to do, copy all my data across from my old laptop. And then he's got a section here on what didn't work for him the first time, which some of these maybe are things we can fix, but could be helpful anybody else running into similar issues. So, in conclusion, is FreeBSD ready for the desktop? Yes and no. Yes, in that I have a very nice FreeBSD laptop where everything works the way I want, But knowing that it took me 2 months worth of fiddling with this in my spare time to fix some of the glitches which arose. While there wasn't anything particularly challenging, I expect that most people would have given up long before they fixed some of the issues that I ran into. On the other hand, can FreeBSD be ready for the desktop? Absolutely. I've fixed the issues I ran into, and once we have FreeBSD 12.2 out with packages built, with that release and the process of bringing up the GUI is just a little bit easier as well. The biggest thing FreeBSD needs is to have developers acquiring laptops and carefully working their way through the issues which arise. The FreeBSD Foundation has already started doing this, and I hope in the months to come, they and other FreeBSD users will report or will publish reports telling us which laptops work and what configurations they needed to change.
Yeah, I like the level of detail from like basically ordering to installing and making all the changes in the system. You don't see that very often for a developer type laptop.
Well, in particular with this, having that level of detail is kind of what we need for the people that work on the different parts of FreeBSD to be able to see these from a bunch of people and be like, okay, there's some steps that we could make to make this easier. Like, I'm not sure how we found some of the sysctlcs did for getting the audio to group the headphone jack and the speakers into the same set so that only one works at a time or whatever. On a slightly different laptop, I'm sure the process is very similar, but I'm not sure how you would figure it out other than guessing. When my laptop has 5 audio outputs and I wanted the stuff to come out the right one, I had some USB speakers plugged into it and I wanted to use that instead of the built-in speakers. And it was mostly a matter of just changing the default to each one while playing sound until I heard the sound come out the right place.
Yeah, definitely a good start, and it should be fairly straightforward to port these instructions to a different laptop because they're not too specific.
Yeah, and in the end, if we had more of these collected, it might be possible to even automatically detect some. Like at some point, we might have package install FreeBSD-laptop, and it would look at the model of laptop you have and be like, here's a bunch of settings that are known to work by default for this machine. This will automatically make the bat light work, and this will automatically do this and that. Although, it's only going to cover some small subset of laptops, but it could keep growing over time.
So yeah, thank you, Colin, for this write-up. And yeah, definitely follow Colin's blog. He occasionally posts not just about laptops, but also about other work he's doing. Then we have an article about the PFS tool changes in DragonflyBSD.
Yep, so this is for Hammer 2, and it says, Hammer 2 has just become a little bit more do what I mean. The PFS-list and PFS-delete directives will now look across all mounted file systems, not just the current directory's mount point. So PFS-delete won't delete any file system name that appears in more than one place, though, because obviously it's ambiguous which one you mean, and we wouldn't want it to delete all of those. We want it to let you specify which one you want.
Mm-hmm. All right, time to jump into the BSD bits this week with BSD templates.
Yeah, so these are kind of like the Docker things we've seen before or whatever, but these are basically FreeBSD jail templates already set up with an application. Whether you want PerconaDB or Asterisk or DNS mask or an Nginx to serve your Poudre packages, or a syslog-ng server, or Bootstrap to be able to run Rust, or if you want to run Telegraph or InfluxDB, an Unbound server, an OpenJDK application, Python, Yarn, a Jenkins setup, NPM setup, Elasticsearch, GitLab, Memcache or Varnish, PHP or WordPress, a Redis database, HAProxy, Console, Postfix, MySQL, Perl, a Node server, Kibana, Prometheus, the stats thing, MariaDB, a Salt master or a minion, a Plex media server, or anything like that.
Oh yeah, these are fairly common applications you might want to run, and if you want to save a bit of time, then run this with BSD.
Mm-hmm.
Then we have a Tiano Core update on the DragonflyBSD digest. Reading, if you have UEFI hardware, there's been an update in Dragonfly on the Tiano Core EDK2 headers. If you are like Justin Sherrill, who wrote this, you will find the tianocore.org site helps to understand what this is for.
Yes, and I know there's similar work going on for the EFI implementation in Beehive to get updated as well.
Oh, excellent. So there's nice progress being made there. And we want to remind you about the FreeBSD office hours on June 24. This is a live event where you can tune in and either listen or ask questions to the FreeBSD crowd that's there, users, developers, sysadmins, whatever shows up there. And that's your way of interacting with the project a bit more direct rather than sending an email to a mailing list.
Yeah, it's kind of a cross between a bit of a user group meeting, but not quite as informal as that. But a little bit like the Birds of a Feather session that we've had at BSDCan for the last couple of years, or kind of a panel type thing where you have a bunch of developers that can help answer your questions. But yeah, if you have questions or there's bugs you'd like to get looked at, or you just want to hear more about FreeBSD and know what's going on, office hours is a little bit more interactive than obviously this podcast is only. The only interaction we have is when we read your feedback questions.
Before we go into the feedback and questions, we should mention the sponsor for this episode, which is Tarsnap, of course. Check out Tarsnap if you have still not made any proper backup that's not on site. So if you do backups, you should put them somewhere where you can retrieve them in case something locally goes very wrong, like your hard disk dies or something else goes haywire. So you should pull this down from the network, but if you put stuff on the network, everyone else can read it potentially, unless it's encrypted, and that's where Tarsnap comes in. Tarsnap takes your backup stuff, encrypts it locally first before it puts it in this case, the Amazon cloud, and that's where the backups are stored. And the only person who can access that is you, because you hold the key. The key will never leave your system, but only the data, but the data is encrypted. No one can get to it. And if you want to check out the encryption, Tarsnap is completely open source. You can read the client code. You can definitely figure out what it's doing in the background without having any secret backdoors or other things. It's deduplicating your data, so only the unique data between your client or your current files and the encrypted data is archived. So you don't have to upload everything again, which might be taking enough time depending on your backup size. And it's available on a vast variety of systems, BSD, Linux, macOS, with Cygwin even. So there's no excuse to not use Tarsnap and making backups in the secure way. All right, we are back with feedback and questions. We always love getting feedback from you to our hopefully well-known address by now, feedback@bsdnow.tv. That's where you can send us show ideas, things you want to always have known from us or ask us. This is your way of getting in touch with the show. The first one who did this is, I guess it's someone that I know, and probably Alan as well. That's Nicholas. Okay. He's referring to a previous episode regarding the Lenovo E595 from episode 340 that we all remember, of course.
Right. Although this applies, basically worth reminding, this applies to all the episodes. Basically, Nicholas is actually, I think, the leader of the graphics team in FreeBSD and helps work on making sure that all the Xorg related ports are up to date and that all the graphics driver stuff goes smoothly for people. And so he has some suggestions on how to submit bug reports and how to collect the information that's most useful to them if you do have a problem with the graphics on your laptop.
Mm-hmm. Yeah, so thanks, Nicholas, for this work. And Nicholas writes, "Hi, I listened to the episode 340 the other day, and there was a person having questions about running FreeBSD on a Lenovo E595 laptop with an AMD Ryzen 5 CPU and Vega 8 GPU. I'll try to answer some of the questions about that." Great, now we don't have to work anymore. No. First off, the email that is referred to in the question is regarding an issue where a change in current broke at compile time the DRAM graphics drivers. This has been long fixed in the port. Okay, so that's already good to know. Regarding the actual issue, it's very hard to know what's going on without logs, specifically dmessage from the driver /boot/modules amdgp.ko when that is loaded, as well as xorg.0.log from starting X. The submitter mentions that the trouble most likely is loading the driver that is causing the issues, quoting having a really hard time to make AMD GPU driver to be recognized in FreeBSD, unquote. I can't remember on top of my head, but it might be that this GPU is only supported by DRM devel-kmod, in which case the only way to have it running is to use FreeBSD 13 current. In any case, it is probably easiest if this person asks for help on the x11 at freebsd.org mailing list, including hardware information, a problem description, and a D-message with logs that he mentioned earlier.
Yeah, so specifically, if you're having trouble with graphics at all, you should contact x11 at freebsd.org and make sure to give them the part of D message about the graphics card when the driver is loaded, and the Xorg log from when you tried to start X and it maybe didn't work or worked poorly.
Yeah. And again, thanks for the people who make X11 the graphics drivers work so that we have current graphics and well-working systems, especially for laptops and desktop systems. Okay, so thanks, Nicholas, for this follow-up. And next one is Eric with a question. What happened to the videos? And it's short, but nevertheless important. Goes like this. Hi, guys. What happened to the video? The show used to be so much better when you had video on.
Well, video takes a lot more time to edit, and it also doesn't allow us to do the improved audio editing. In particular, because Benedict and I are not in the same room when we record this, even outside of COVID concerns, he lives in Germany and I live in Canada, and there's this ocean in the way and 6 time zones? Because of the delay, we often end up speaking at the same time over top of each other, which is very hard to listen to and not very helpful. When we switch to doing the audio-only version of the podcast, we each record separately, and it is possible to, if we do talk at the same time, space it out so that when you hear it, we're not actually talking over top of each other. Now, if we try to do that with video, suddenly, my lips won't match the sounds coming out, and that won't look right. But mostly just we don't have the amount of time that's required to continue to do video. So it's made it much easier to do the show and make sure that we can keep doing the show by dropping the video. However, if you do really die for the video, we have a kind of best effort version of the video. If you tune in while we're recording, you can watch live, and the DVR buffer. So the live streaming service we use that I helped create uses a system where it actually keeps a buffer that allows you to rewind the live stream. And we keep that buffer available after we finish the stream. So if you go to bsdnow.tv/live, you should be able to watch the show live if it's live. But if it is not live, you should be able to watch the last recording session we did up until we start the next one. You can still get some video if you want, although we don't make an MP4 file that you can download and so on, just because it's much more work and it actually costs us money for the bandwidth. And it was easier to just do audio only. So sorry if you miss it, but there is still some live video if you're really jonesing for some video.
Yeah, so that's a good compromise between audio and video. The last question comes from Igor about boot environments. Igor writes, "Hello, Alan and Benedict. I'm a huge fan of BSD Now podcast. Please keep the show rolling." Yeah, we might as well at this point after like 350 episodes. Okay, yeah, so thanks. Since you often ask for questions on the air, here is mine. I run FreeBSD jail server in AWS Cloud with ZFS on root. I want to utilize boot environments feature to safely try upgrading my system, but the problem is that AWS Cloud does not provide console access to the virtual machine. So I can't really see bootloader screens and provide any input. The only way to access the server is through SSH, which is not there at boot time, of course. Is there a way to use boot environments in such a scenario? Something like try booting the ZFS snapshot once, and if it fails, never or revert back to it.
Yes, actually. So the tool you're looking for is called ZFS Boot CFG, and it does exactly that. So after you've created a new boot environment, instead of setting it as the bootfs property on the pool, you can just do ZFS Boot CFG and give it the dataset name, and it will boot that one time only. If it doesn't work, you can just do a reset or reboot again via the AWS console, and it will boot back up into the old boot environment. This can be made even easier if you're using the new BECTL tool that I mentored a Google Summer of Code student to start and convinced Kyle Evans to finish for me. It has the flag -t for temporary. So if you BECTL activate -t a dataset, it will do it one time only. And so yeah, this will allow you to boot it one time only. If it works, you can make it the new default and it will boot that one every time now. If it doesn't work, you can just power cycle again and it'll fall back to the old version, and that way you don't run into any trouble.
Oh yeah.
I use exactly this procedure on a lot of servers because yeah, if you have 100 machines and you only have console access to some of them, and even if you do, it's a big pain. It's just much nicer to just be like, hey, here's a new version, try it. If it doesn't work, we'll roll back and we'll investigate after. But, is FreeBSD. So 90% of the time it works, or more. Upgrades generally tend to go pretty well. If it worked on 10 servers, it's probably going to work on 100 servers, right? But it is always nice that if something does go wrong, if I made a typo, whatever happened, that a power cycle is all it takes to get it go back to the working system. Super helpful.
Yep, and that's why it works also on virtual machines. Excellent. So thanks for that question. That pretty much wraps up this episode for this week. Keep listening to us, of course, and provide us with feedback. And then we'll be having a future episode for you to listen to. Thank you.